All right, this is going to be Algebra 2. I need to go over the entire pretest problem by problem. So here's the first problem. We have our system of linear equations here. How many solutions does the system have? Well, if we multiply this top equation by 3, then this new equation becomes 6x minus 9y is equal to 33. I just multiplied 3 times 2x, got 6x, 3 times negative 3y, negative 9y, and 3 times 11 is 33. So I have the same equation twice. We see that?
So it's 1?
So the answer here, well, let's see what happens. Let's try elimination, right? If I multiply this whole thing by negative 3, then it becomes negative 6x plus 9y minus 33.
The whole thing's gone.
And the whole thing's gone. You get 0 equals 0. And in our notes, I have if 0 equals 0, that is infinite solutions.
Bro, that's like the one I scratched out.
I know. So 0 equals 0, and you can write this on your pretest because that's going to be stapled in your notebook. 0 equals 0, that means infinite. You can do a little infinity sign. I can try to do a better one. If you have something like 1 equals 0 or 5 equals 0, or some number equals another number that's not the same, that implies no solutions. No solution. If you have x equals 5 like you normally do, that means there's one solution. If you have a system of linear equations, these are both lines, it is impossible to have 2. Every time you see 2 on this unit 1 test, cross it out. It's impossible. It might have 0. It might have no solutions. If it's no solutions, that means you have parallel lines. If it's infinity solutions, it's the same line, and one solution they just cross. All right, let's talk about numero dos. So I have to Alt-Tab and copy these every time. So number 2. I can do it pretty fast. So for a wedding, Sharita bought several dozen roses and several dozen carnations. The roses cost $15 per dozen. Carnations cost $18 per dozen. Blah, blah, blah. Okay, so here we go. We need a variable r. I don't know why that's not going away. There it goes. A variable r and a variable c. Both of these are flowers. $8 per dozen. Oh, this one is actually, you don't have to set up a system of linear equations, do you? So if you bought a total of 17 dozen flowers, oh, so you do have to do it. Okay, so you have to say r plus c is equal to 17. You add, the unit here is dozen, so roses plus carnations added up to 17 dozen. So this is our equation for how many dozen. And then from there, we know that we actually have to pay for these. So $15 for roses and $8 for carnations. And that's going to be a total of 192. And that was the equation for money. So we had one equation for the counting, one equation for money. That's usually going to be the case. And then we solve. So I think the best way to do this is substitution. So I'm going to make this equation now r is equal to, so here's a trick. If I know that I'm trying to solve for roses, I need to get rid of carnations. So whatever I set this equal to, c equals something else, I'm going to get rid of this variable that I substitute in. So c equals 17 minus r, plugging that into my equation over here. So I'm rewriting it 15r plus 8 times 17 minus r. I just substituted in for c, equals 192. Okay, multiply this through. I still have my 15r plus 8 times 17. Well, 8 times 7 is 56. Carry, it's 136. Minus 8r equals 192. Let me just double check that I did my math right. 56. 5 plus 8 is 13. Yeah, 13.6. All right, so from here, I'm going to 15r minus 8r, and that's going to be my 7r. And then I'm going to subtract 136 from both sides, and I will get, what is that going to be, 56? That seems about right. And then you get r is equal to 8 after you divide both sides by 7. And there it is, roses equals 8 dozen. All right, I do have to go kind of fast because there are quite a few problems. If you want to rewatch the video, you may, or slow down the video. All right, so which of the following solution or systems has no solution? Remember, no solution means you have something like 1 equals 0. So let's go ahead and go through these. Are there any likely candidates?
D.
Yeah, so D is a very likely candidate because if I subtract the 3x over, I get y equals, subtracting the 3x, negative 3x minus 3. And my top equation, we can multiply the whole top equation by negative 1. That will make it a negative y equals a positive 3x and then a minus 4, just multiplying 1 through each term. And then I can do elimination. I can keep adding straight up and down. So y minus y, that's going to be, or negative y plus y is 0. 3x minus 3x is 0. Minus 4 minus 3 is a negative 7, and I get 0 equals 7. This implies that there's no solution. So the correct answer here is D.
Nice. Got that one right.
Nice. All right, so let's go ahead to our next problem. Numero 4.
It's not stable, but it's not leading.
Are you okay, Johnny?
Freaking shit. Hey, it scraped on the table. Just what-
On this table in here?
Huh?
On this table in here?
Yeah.
Oh, dang. Okay.
I only had like,
Soup is
I had
just
this
no
scab
French.
already there.
Oh, so it ripped out the scab?
Yeah.
Soup.
All right. So number 4, here's the trick. You guys are always liking the tricks. So on the test, you don't actually need to solve this. You could, but an easier way is just to plug in these numbers and to see if you get a number equals a number. If you get something like 4 equals 4, that means it worked.
I got the
And it has to work for both of these. So-
I just went from the answer. I took the answer and just put it in.
Yeah, exactly. Yeah, that's a shortcut for these. So I plug in 2 and 3, and that's going to be 2 plus 6 equals 4. Okay, not A. Let's look at C. You can alternate colors for C. So I'm plugging in negative 3 into the x. So negative 3 plus 4. Is that equal to 4? Nope, it's not C either. All right, let's try 2 and 1. If I plug in 2, 2 plus 2 equals 4. Oh, okay, it might be B. Let's see if we can eliminate D really quick. So far it might be B, but we have to sub it into this one. Actually, we can just sub into the second equation, 2 and 1. So that's going to be 2 times 2 is 4, plus subbing in 1 plus 1. That should equal 5. Oh, it works for both of those. It must be B. All right, and let's go to number 5. So there's number 5. And which of these is a solution? And again, you're just plugging in. That's the easiest way. And that is showing that they work. So if I plug in 3 and 5, that's going to be 2 times 3 plus, I don't know what I'm doing there, plus 3 times 5. That should equal 21. And from there, I get 6 plus 15 does indeed equal 21. So it might be A. Let's check if it works for the second equation. Remember, this has to work for both equations in order to be a solution to the system. So plugging in 3 minus 2 times 5 needs to equal negative 7, and that's going to be 3 minus 10 is equal to negative 7, and oh yeah, that is the case. Yeah, so the correct answer is A. It worked on the first try. Lucky yes. All right, so number 6. We are now on standard E.
I can't.
All right, so which is a solution of that system? All right, let's just plug both these in and see if they work. So if I plug in 0 and 3, 0 into x, it's going to be negative 2 times 0 plus the negative 3 is being substituted in. Should be less than or equal to, oh, that's a positive 8. I was going to write a negative 8. So this is saying, this is the same thing, gentlemen, as negative 3, negative 3 is less than or equal to 8. Is that true or false? Is negative 3 less than or equal to 8?
Yes.
Yeah, that's true. So it works for that one. And let's plug in 0 and negative 3 to the second equation. So it's going to be
No, it's D. It's D.
0 minus 3 times negative 3. That needs to be greater than 9. Just plugging into the second equation. And that's going to be the same thing as saying negative 3 times 3 is 9. 9 needs to be greater than 9. That is not the case. 9 is not greater than 9, so it can't be A. And by process of elimination, it can't be both A and B if it's not A. So it's either B or D, and now we have to check for B. So plugging in 0 and 9. And if I plug in 0, that's going to be negative 2 times 0 plus 9 needs to be less than or equal to 8. And that's going to be 0 plus 9 needs to be less than or equal to 8. 9 is not less than 8, so it's not B either, and therefore the correct answer is D. All
This next one I got wrong, and I don't know why.
All right, well, let's figure that out.
It was probably.
I know why. Because you pressed you circled the wrong one.
Yeah.
All right.
That was weird.
Which of the following is a solution to this one? All right, so I like to start these by doing a quick graph, a little sketch. It doesn't have to be perfect, just to get me in the right idea, and then I'll plug in the one that I think is right. So on my quick graph, this is going to be the same thing as I'm going to subtract a 6 over, or subtract an x over, so it's going to be negative x plus 6. I subtracted the x onto this side. And then I know that this is going to be y, on the same line, this is going to be y is less than or equal to negative 1/2 x plus 6. So I'm going to say 6 is right there, and a slope of negative 1/2 is going to look roughly like that. And I know that this is y is less than, so it's going to be down here somewhere. Okay, and I know this equation is going to become y is greater than or equal to 3x plus 4. So plus 4, I'm going to say that's right about there, and a positive 3x, that's going to be a really steep slope like that. Maybe I should have done that in a different color. I can do this in red. So this guy is now in red. So steep slope like that, and I know it's greater than. Greater than, is that to the right or is that to the top?
Less than, greater than.
Right, but in terms of a graph, when I say greater than, does that mean go up or go to the right?
Up.
That means go up, so something above this. So I'm looking for something over in this area. Well, at 0, 5, it looks like it is, that's a possibility, maybe a. Negative 1, 2, so negative 1, 2, that is also a possibility. Negative 1, or 1, negative 1. So 1, negative 1, that's over here, and that's not in my sketch. And 0, 0, that's right here, that's not in my sketch either. So it's between A or B. So my sketch eliminated 2 without plugging in a ton of times. Let's try A. So if I plug in 0 into y, so 5 is y, so it's going to be 2 times 5 plus 0 needs to be less than or equal to 6. And that's going to say 10 is less than or equal to 6. That is not the case. A is eliminated, and therefore the correct answer, D was already eliminated also. Correct answer is B.
B.
All right.
It was B.
It was B.
Dude, I was freaking. I guessed the wrong one. Damn it.
All right.
Guessed the wrong one.
No, because they both fit in the damn thingy.
All right, so number 8.
It's just, no, I think you should just dumb these tests down about like $4.
No, I'm giving the same test to everyone.
That's not cool.
What system of inequalities best represents the graph shown below? Okay, so this one. This is a y. Y is it greater than or less than? It's above this line. So, gentlemen, this is where you participate. Is it a greater than or less than this line?
Greater than.
Yeah, greater than. It's above the line, so greater than negative 2. So it can't be those two. And now,
Of course.
we don't even need to know the line. Is it above or below this other line?
It's A.
It's below, so it should be less than.
No, it's B.
So it's B. This says less than. So this symbol means below, and this symbol means above. You should have
Two
that.
of us, we could have figured it out, me and Jack. Because
What?
I got C,
No.
and he got A, so we could have got it.
Well, that could have turned into a D as well.
No, I knew it wasn't. I knew it
No.
wasn't C or D.
Okay.
Because those was like crossed out. I had B and A like little underline like.
Between the two of us, we could have figured it out.
Sadly, it was not a group test. Maybe in the
You should
future.
make all tests group tests.
I need to assess individual learning at some point too, though.
Do you do what?
I need to assess individual learning at some point as well, though. All right, so let's go ahead and make a quick sketch of this so we know roughly where we're going. Maybe we can eliminate all of them. So this equation is going to become, I'm going to add the x over, and it's going to be 2y is greater than or equal to x minus 6. Again, I added the x over. And then from there, I'm going to move up here because I'm running out of room. I'm going to divide everything by 2, and I'm going to get y is greater than or equal to 1/2 x minus 3. So what does this equation look like? 1/2 x minus 3, I'm going to come down 3, and 1/2 x is going to be a slope that looks roughly like this. All right, let's do our second equation. Doing the same thing, I'm going to add the 3x over. I'm going to get 2y is less than 3x minus 6. Divide everything by 2, and I get y is less than 3/2 x minus 3. So again, at minus 3, so I have this y-intercept, and I need to come up with a slope of 3/2. So it's almost 2, but not quite, so it looks like that. And for the red line, it's below, so down here. And then for the blue line, it's saying y is greater than or equal to, so it's above the blue. So above. So I'm looking in this area, this region over here. So let's see which of these matches up. So gentlemen, we do need to be paying attention. So at -4, -1, that's -4, -1, that's right about there. That's definitely not in this region. It can't be A. Let's look at B. B is saying 3, 1. So at 3, 1, that might be in the region. That might be like right there. Let's look at, oh, and by the way, there is a slight error in my graph. This red line should be a dash red line. I'm noticing that now in retrospect. Let's look at C. 0, -3. 0, -3, that is not included because remember, the red line is a dash line. It has to satisfy both of these. It doesn't satisfy the point at 0, -3, so it can't be C. That's a very hard thing to see. Did you guys see why I eliminated C?
Because it only goes on the line, and that line is not equal to, it's just a greater than.
Exactly.
Yeah, less than.
Yep. And then let's look at this one. That's going to be 4, 3, 4, and then up 3. That's a maybe. I'm not sure about that one. So we have to check B and D. All right, let's check B first. So if I plug in for x and y, so it's going to be 2 times 1 minus 3 should be greater than or equal to -6. So it's going to be 3 minus 3 needs to be greater than or equal to -6. 0 is indeed greater than or equal to a negative. Let's check the second one. So plugging in x and y, so I have 2 times 1. Again, I'm plugging into this equation now. 2 times 1 minus 3 times my x was 3 should be less than -6. So this is going to be 2 minus 9 needs to be less than -6. And my 6 is weird there, but that's a -7. Is -7 less than -6?
Yeah.
It is, yeah. So it's B.
That was really confusing.
All right. Number 10. I have to figure out what inequalities it's talking about here. So, what do we have here? All of these are different equations. So, let's look at this one. This one has a y-intercept of 3 and it has a slope of a half.
I knew I was going to get that one wrong.
So y-intercept of 3, there's the y-intercept of 3, and a slope of a half? Oh no, that's way too steep of a slope. It can't be A. That's the wrong equation. Let's try this one. This has a y-intercept of 3, y-intercept of 3, okay, could be this line, and it has a slope of 2. Oh, that's a slope of 2, right?
Yeah. Shit, that's why I got wrong.
No, it's not. Why is it not a slope of 2 right here?
It is too.
It goes
down and then go over 1.
It goes right 1, and then does it go up 1 or down 1?
Oh, it goes
Down.
up.
It
This goes
goes
down
down,
1.
does not go up.
No.
So this, if this was a -2, then that would have been okay, but it's not that one. All right, so let's look at this one. So if let's go turn it into y form, y equals mx plus b form. So I'm going to subtract the 2x over, so it's going to be -y is less or greater than or equal to 3, and then I subtract the 2x minus 2x. And then let's get rid of that negative, so this is going to be y is less than or equal to, look, I switched the sign because I'm multiplying by a -1, and then it's going to be a -3 plus 2x. Do any of these graphs have a y-intercept of -3?
Yeah.
There's -3. Do any of these graphs go through that point?
Not even close.
No, yeah, exactly. So just by process of elimination, it's D.
Oh, thanks. That was the first one. Process of not wait. You get the right answer.
All right, number 11. I might be able to fit multiple of these on the same slide. We'll see. All right, so if I have y equals something and y equals something else, go ahead and set these equal to each other. Sub in this whole thing for the y value because this is y. Y equals this, therefore this is y. Plug it in for y and you get x plus 3 is equal to 2x minus 4. You set them equal to each other. Once you have that, then go ahead and solve. I'm going to subtract x, and 3 is equal to x minus 4, add 4, and x is equal to 7. Am I done? Am I done?
No.
What do I have to do?
Solve the y.
Gotta solve for y. So y was equal to something plus 3, the x plus 3, and x is now 7 in my first equation. Therefore, y is equal to 10. There are my two answers. Y equals 10, x equals 7. I can fit another one on here.
I get y equals negative 10. And x equals negative 30.
So, yeah, part of the assignment tonight is to look at your errors and figure out what your errors were.
I got y equals 2 and x equals negative 1. Oh god, this is rough.
Okay, here we go. X minus 2, that is y. That gets substituted in for this variable y. So let's rewrite this line, but instead of y, we write x minus 2. So 4x plus 2 times, now I'm substituting x minus 2 is equal to 20.
Never mind, yes, it did.
All right, so this is going to be 4x plus distributing the 2, 2x minus 4 is equal to 20. And then from there, I'm going to combine like terms. 6x minus 4 is equal to 20. I'm going to add the 4 over, plus 4 on both sides. And from there, I have 6x is equal to 24. And x is what, gentlemen?
X equals 6.
Nope.
4.
There it is, 4. All right, there's one of our answers halfway there. X equals 4, and we knew we had the equation y equals x minus 2. Well, that x is now 4. Therefore, y is equal to 2. Okay, I shouldn't box that. I should box the entire thing. All right, so far so good. And last but definitely not least, we have 13. This looks like something that we can do another substitution problem. So let's use black here.
I didn't do a substitution.
Please substitute.
So this whole thing is x, therefore this whole thing will get substituted in for x. So let's rewrite this. 2 times that substituted x, y plus 4, plus 3y should equal to 43.
I did elimination. I still got it right.
Oh, nice. Yeah, you can use either way. I think substitution works a little bit easier here. So distributing the 2, this is going to be 2y plus 8 plus 3y is equal to 43. And then combining like terms, that's going to be 5y plus 8 is equal to 43. I subtract 8 from both sides, subtract 8. I get 5y is equal to 35. Divide both sides by 5, divide both sides by 5. And I get y is equal to 7. Half of the answer should be equal to 7. Now that y is equal to 7, I know that x is equal to that y plus 4 from my first equation up here. Therefore, I plug in 7, and I get x is equal to, gentlemen?
Negative 6.
What?
Wait, 11. Sorry.
Negative
I
6.
was looking at a problem.
Yeah, you're good, Johnny. Okay. I'm just trying to make sure that we're awake while still going fast.
And then the other one,
I guess I can just copy and paste all of these now that I know that I can fit them all in. All right. Here we go. Number 14, here we go. I know that x is equal to all of this, so therefore I can sub all of that into x. So 2 times all of that, 3y minus 3 plus 5y is equal to negative 17. What do I do now, gentlemen? Something over here?
Distribute.
Distribute, yeah. So it's going to be what? Read it out.
It's going to be 6y minus 6 plus 5y equals negative 17.
Perfect. And then I'm going to combine like terms. Johnny, to get how many y's? How many y's am I going to get here, Johnny?
What are you talking about?
6y plus 5y?
Oh, 11y.
11y. I'm going to add 6 to both sides. And I get 11y is equal to negative 11. Therefore, y is equal to?
Negative 1.
Negative 1. And I have to plug that back in because I'm not done. So I had x was equal to 3 times that y minus 3. That y is now negative 1. 3 times negative 1 is negative 3 minus 3. And therefore, x is equal to?
Negative what? Oh, so I totally freaking got that wrong.
All right. And next problem. 15. This is one that definitely works with elimination. I can just go ahead and add these.
I didn't even know.
3x plus negative 3x is how many x?
0x.
0x. And then 4y plus y is equal to 5y. And 23 plus 2 is 25.
I don't even think that.
Divide both sides by 5. Divide both sides by 5. And we get y is equal to 5. All right, so almost there. I need to sub back in. I have a negative 3x plus my y value is equal to 2 coming from our second equation. And plug in our 5 for our y. We have negative 3x. And I'm going to subtract this 5 from both sides to get negative 3x is equal to negative 3. And therefore, x is equal to what, gentlemen? Divide both sides by negative 3 to get?
0. 1.
1, yeah. All right, and then this one was the hardest one because you had to do elimination or substitution somehow to do this one. You can actually do both about the same difficulty level. Should I do elimination or substitution?
Elimination.
Elimination. So let's go ahead and get rid of these. What do we want to get rid of? The y's or the x's? X's. Notice that the x's are here and here and the y's are here and here, so you do have to kind of move them around. So if I move this one around, it's 3y minus 5x is equal to 23. So in order to get rid of the x's, I think that's what you said, Jack?
Yeah, I think it'd been easier to get rid of the y's though.
Let's get rid of the y's then. So if I multiply this whole thing
By 2.
by 2 and this whole thing by
Trace.
negative 3, then my new equations become, this negative 3 is going to be negative 6y plus 12x is equal to, what's 18 times 3?
Yeah.
I think it's negative 54.
52.
And then multiplying all of the 2 through our equation becomes 6y minus 10x is equal to 46. And then let's go ahead and add those. That line was a little bit off. Add these up. And the y's go away. We have a 2x. All right, so I have a 2x, and I have a negative 54 and a 46. That is going to be a what? Gentlemen, negative 54 plus 46.
It's like negative 8.
It is negative 8, and therefore x is equal to
Exhausting. Negative 8. Negative 4.
negative 4. And plugging back in, we have, let's
All
just,
real numbers.
2y minus 4 times that negative 4. Plugging in for that negative 4 equals 18 into my first equation. And we have 2y plus 16 is equal to 18. Subtract 16 for both sides. Subtract 16. And I have 2y is equal to 2. Therefore, y is equal to what?
1.
There it is, 1. All right, moving fast and furious, going through this. We have number 17. It's a little bit off. The hole punch got it. So negative 17, or sorry, problem 17. Problem 17 is y is greater than or equal to this number. So y-intercept is 1, and my slope is 3, so I go right 1, up 3, or I can go left 1, down 3, and I need to make a line that goes through that. Is it going to be dashed, or is it going to be straight? Is it solid or dashed?
That right there is a dash.
That right there is dashed? Yeah, Johnny?
It be solid.
Solid.
Uh-oh. Is it solid or dashed?
It's solid.
Solid, yeah.
Son?
A solid line that goes through these points, like that. And is it shaded above or below?
Down.
This says greater than.
So go to the greater than side.
Greater than means above.
Damn it, you're wrong.
So on that side, above the line.
Oh, you're wrong.
Okay, I guess I can put 18 on here as well.
Mr. Sandell, did you really need to shade in this little bit on here?
Yeah. Because that's the correct answer. All right, so x is less than negative 1. So I go to negative 1 on the x-axis, which is this axis. I should have labeled that x. And negative 1 is right there. And is it going to be a dashed line or a solid line?
That there's gonna be a solid dash.
A dashed line through that point. And then is it going to be to the left or to the right for the shaded region?
We're going that way.
That way. What is that way?
Left.
Left. Yeah, it says less than, so it's left. It's this area over here. Perfect. All right, let's do number 19.
I never listened to that song outside.
I can zoom out here to capture it. Number 19.
I don't think that song actually exists unless you're upcoming.
Yeah, I'm gonna.
All right, so how do I do this problem? Let's go ahead and get it in y form. So I'm going to subtract the 6x, subtract the 6x, and I have negative 4y is greater than negative 6x minus 2. Divide everything by negative 4, divide by negative 4, divide that by negative 4, divide that by negative 4, and my new equation is y is it going to be greater than or less than?
Greater than.
Greater than like that?
Wait.
Y'all.
Yeah.
Nope, I'm dividing by a negative. So whenever I divide or multiply by negative, it flips.
Less than.
So it's going to be less than now. And then this is going to be 3 halves to reduce a fraction, x. And this is going to be plus 1 half. So I come up 1 half, and I can just say that's right there if every unit is 1. And then I go up 3 over 2. Up 3 to the right 2. 1, 2, 3, and then right 2 is going to be right there. And same thing, I can go down 3, 1, 2, 3, and then left 2. And I need to make a line. Is that line going to be dashed, or is it going to be solid?
That's going to be dashed.
It is going to be dashed. All right, and then is it going to be shaded above or below? If it's y is less than.
Below.
Below.
Above.
Above.
Below. All right, so here we go to number 20, that mega problem.
Dude, I actually got that right, though.
Yeah, you did a good job on number
That was
20.
the only one I got 3 out of 3.
The only one.
There's number 20.
Crap.
So graph all those.
Crap.
So let's do the easier ones first. X is greater than 1, so I come to x at 1, which is right there, and I make a solid or dashed line.
1.5 on
Solid.
Solid or it's a greater than not equal to. So it's a dashed line there.
Wait, what one are we on?
I'm doing this the second
Oh,
equation.
the middle
Yeah.
one, okay.
What about the last equation?
That's going to be another dash line.
This can be another dashed line. We
But
can do
you
that.
go the opposite way.
And red, yeah, it's going to be up here at 5. 1, 2, 3, 4, 5. So there's that line. And let's go ahead and shade these two. So the black line is going to be shaded to the left or the right. This one was the black.
It's to the left, to the left.
This is saying to the greater
Oh,
than.
wait, it's to the right, it's to the right.
So in that direction. And then the red is going to be above or below.
Obviously down. It's downwards.
Below. Somewhere down here. It looks like we have this little area down here. And then the final question comes right here. We'll do this in blue. This is going to be y is greater than or equal to. I'm going to subtract 1, so 2x minus 1. Therefore, my y-intercept is negative 1. Y-intercept is negative 1 and has a slope of 2. That means right 1 up 2, right 1 up 2, right 1 up 2. And, oops,
Oh, I didn't change it. That's
coming down here. Is that going to be a solid or a dashed line for that?
Solid.
Solid.
Dude, solid dough.
Oh, I didn't even shade it. That's probably why I got 1 blue.
Yep. Okay, so
If I shaded
then from there, is it going to be shaded above or below the line?
above.
Above. So if it's shading above, then all 3 of them intersect in this area right here.
And we have just enough time to play Slash Dash.
All right. And that is the end of the pretest. All right, so instructions for the boys and the girls that are listening to the video. You now need to finish your fix-up. Once your fix-up is done, then start on your test. You guys are going to have your test starting tomorrow on Friday. The fix-up for you gentlemen is going to be due before the test.
Aye.
So tomorrow your fix-up is due before you enter the classroom. It is the most important homework assignment you do for the entire unit because it's 20% of your entire grade.
Oh, shit.
Why you got to make it so crazy,
All right.
though?
That concludes the notes. You guys want to say goodbye to the girls?
Nah.
Oh, Thea.
They be